Hello everyone, Mr. Cruze here. This video will cover the first part of the 8.1 to 8.4 quiz review, which is a quiz that you'll be taking tomorrow. Alright. Number 1 just asks you to factor. You've been doing this since first semester, okay? Technically, before you start factoring, you must always look for a common factor, a greatest common factor. In this case, it's 1, so there's nothing you can pull out. But this 5 is still out front. So you have to take the 5 times the 6, and you get 30. So we need two numbers that multiply to 30, and add to the middle number, which is negative 17. The two numbers to do that are negative 15 and negative 2. So I split up the middle term. 5x squared minus 15x plus a negative 2x plus 6. I like to have the plus negative in there. Put parentheses around the first two and the last two. What comes out of 5x squared and negative 15x? That's a 5x. And you're left with x minus 3. Over here, a negative 2 is the greatest common factor, and you're left with x minus 3. You'll notice that both of these are the same, so we're good. It factors into x minus 3 and 5x minus 2. And we now know that factoring is going to be very, very important for what we're doing on this quiz. The next part was the properties of exponents. Okay. So, simplify each expression, use only positive exponents. Remember, no negative exponents, okay? 4x to the 0, y to the negative second. Well, anything to the 0 power is 1, okay? So really, this just kind of goes away. So you're left with 4y to the negative second. Anything with a negative exponent is unhappy where it is, so it needs to switch places in the fraction bar. So the 4 technically has power 1, so it stays on top. The y to the negative second goes to the bottom, and it becomes positive. Alright, and nothing else cancels, so that's it. Number 3, the properties of exponents tell us that we can distribute any power that's on the outside to everything on the inside. So technically, you have negative 4 to the third. You have a to the what power? Here you multiply these two powers together. 2 times 3 is 6. B to the 4 times 3 is 12. C to the 7 times 3 is 21. Only thing you have to take care of now is what's negative 4 to the third. That's the same as negative 4 times negative 4 times negative 4, which in this case is negative 64. And then you still have a to the 6th, b to the 12th, c to the 21st power. Number 4. There's a couple ways you can handle this. I'm going to go ahead and move the negative exponent upstairs to make it happy. So it becomes b to the third over a squared times, I'm going to do the same thing here after I distribute the power. So we have a to the negative second, b to the positive third, which means this a to the negative second is going to go to the bottom. So you're left with b cubed over a squared times another b cubed over a squared. And that a squared went to the bottom. When you multiply two variables, as long as they're the same variable, you add their exponents. So b to the 3 plus 3 power, which is 6, over a to the 2 plus 2, which is 4. B to the 6th over a to the 4th. Number 5, I'm going to distribute the negative 1 power to everything on the inside. Everything. Once again, the s to the 0, you really don't need to worry about it. It's still going to just be 1. It goes away. This now becomes r to the positive first power. Remember, you're multiplying here. S to the negative second, t to the positive third, over r to the positive second. The s, remember, it goes away. Anything to the 0 power. And this will be t to the negative 1. The only thing you have to do now is kind of switch your exponents places. So this would be r to the first, the s squared goes to the bottom, t to the third. This t to the negative 1 is going to go up top. Alright, so we also have a t to the first over r squared and then the s to the second. Combine like terms, r to the first, t to the fourth over r squared, s squared, and then now you technically have to cancel these r's. You have one of them up top, and you have two of them in the bottom. So this r to the first divides into this one, leaving you with an r to the first in the bottom. So you get t to the fourth over rs squared. By the way, you could also have subtracted their powers. R to the first over r to the second would be r to the 1 minus 2, which would be the same as r to the negative 1, and of course you know r to the negative 1 must go to the bottom, which is why it's the first in the bottom. Okay. Number 6, last one of the properties of exponents. Distribute the power. Negative 4 squared is 16. X to the negative 6th, y to the 10th, times 1 over 16 x to the negative 6th, y to the 10th. And you'll notice, yeah, these are negative exponents, but they're the same, right? So even if I did switch their places, they're still going to cancel. The 16s cancel, the y to the 10ths obviously cancel, and of course x to the negative 6 will cancel as well. So this one reduces simply to 1. Pretty easy, huh? Watch out for tricks like that tomorrow. Let's see, direct variation. Direct variation means y equals kx is the form you're looking for. So can we try and rewrite these so that these are in y equals kx form? Sure, divide this one by 6, and you get y equals negative 11/6 x. Does this look anything like this? The answer is yes. So this is your k value. So k equals negative 11/6. So yes, it varies directly. K equals negative 11/6. Number 8, you're trying to get y by itself again, and you get y equals negative 2x plus 4. Does this look like this? No. Notice there's nothing being added on over here. So this is no. And obviously if it's no, there is no constant of variation. It doesn't change. Okay. Number 9, a lot of us had a little difficulty with. So y varies directly with x and inversely with y. All right, y varies. So that's going to be y equals directly with x. Well, you're always going to have k, no matter what. All of these are going to have k. Since it's direct with x, that means x is with the k value on top of the fraction. It's in the numerator. Anything that says direct is going to be in the numerator. Anything that says inverse is going to be in the denominator, inversely with z. Okay? We're so close to having the function, right? We just need to figure out what k is, and we're good to go. They tell you x is 6, y is 15, z is 2. So let's plug that in. Y is 15, x is 6, and z is 2. 6 over 2 is obviously 3, so 15 equals 3k. Divide by 3, and k equals 5. So I'm going to replace this k with a 5. There's the function that models the situation. Okay? Then they want us to find, this is supposed to say z, right? When x equals 4 and y equals 9. So I'm going to plug in 4 and 9 here. Y is 9 equals 5 times 4 over z. Now, how do I solve for z? Z's in the denominator. Well, that's okay. Put this over 1, and you guys know what to do with this. Cross multiply. Since there's an equal sign, you can do that. 9 times z is 9z. 1 times 5 times 4 is 20. Divide by 9, z equals 20 over 9. Not so bad. And lastly, for this video, number 10, suppose x and y vary inversely. Okay, inverse variation uses this formula, y equals k over x. Remember, if it's inverse, it's going to be in the bottom. X equals 8 when y equals negative 7. So, plug in negative 7 for y and 8 for x. Once again, to solve for k, you can cross multiply. You get negative 56 equals k. Plug that back in here, and you get y equals negative 56 over x. That's your equation. And then I want you to figure out what y is when x equals 2. So y equals negative 56 over 2. A quick punch in your calculator, or if you can do it in your head, that's great. And it ends up being negative 28.